Okay, class, turn to page 33. Let's do question number 4. The force of gravity on a bridge in the diagram below is 960,000 newtons. What upward force must be exerted at the end, at Q, to support the bridge and the truck that's on it if the force of gravity on the truck is 48,000 newtons? Hint, treat the bridge as if it were a lever with an imaginary pivot point at point P. And what torques tend to rotate that lever around point P? So I'm going to draw my free body diagram. Okay, of a rigid body. I'm going to label the pivot point here. The pivot point is at point P. Wow, thanks for subscribing. That's not. There's a force of gravity down, the force of the center of gravity of the road, of the bridge itself. And there's the force of gravity of the truck. And there's the force up at point Q. That's the free body diagram. I'm now going to, in theory, ruin it by putting numbers into it. So this is going to be 960,000 newtons. The force of gravity of the truck here is 48,000 newtons. This distance here is 8.5 meters, and this is another 3.5 meters, and this is another 5 meters. So we'll do the sum of the torques. The sum of the torques is 0 because it is not rotating. It's in static equilibrium. It's in rotational equilibrium. Now, if you wanted to be a little bit honorish, you would say, where is the pivot point? Because we can't change the pivot point while we're doing this. We set the pivot point, so this will be that the pivot point is at point P. You don't need to do that. It's going to be pretty obvious from your free body diagram that you're setting it there. So the torques clockwise is equal to the torques counterclockwise. That'll be the torque of the center of gravity, because that'll make it go clockwise. So observe. It'll make it go this direction. That force will make it rotate that way around that, and that's a clockwise direction. I will then add the torque of the truck, which is in the same direction, and that has to equal the torque of force Q. Okay, why is that in the opposite direction? Because that force is up, and it'll make it rotate that direction around that pivot point. So there is my default set of lines. I'm doing it by torques, and this is how it applies to this free body diagram. Now, torque is, the formula from yesterday, is the applied force at the distance from the pivot point, that's the radial arm, times the sine of those two vectors, the angle between those two vectors. And all these forces from this diagram here are meeting at right angles, and that force is straight up at right angles. So the sine in each of these cases is 90 degrees, and that sine is going to equal 1. So just to be a shortcut step, I'm not going to even write this in today's solution. I'm not going to put the sign there because it's going to be 1. So this is going to be force times distance plus force times distance is equal to force times the distance. This force of the center of gravity is 960,000, and its distance is 8.5 meters. I now add the other force onto it, which is 48,000 newtons times the distance. Now that's the distance to the pivot point. It's the torque about that pivot point. And that distance is, from the diagram here, says 12, or it's 8.5 and 3.5, which is 12. So this should be 12 meters. And that has to equal the unknown force, FQ, times the distance that FQ is being applied at, which is a total length of 17 meters. That's how long the bridge is. Now, if you stand back a second and take a look, this is how it applies, that step there. These are the formulas in expansion, and these are the numbers being plugged in. Now you just start multiplying and dividing and adding and subtracting, doing all that stuff to solve for FQ. So I'll write down the in-between steps. It's a good idea to do so. It's called showing your work. Times 8.5. This will be the torque of the bridge itself around that point, which is 8,160,000 units are Newton meters. That's the torque caused by the bridge around that pivot point. The truck is 48,000 times a distance of 12, which 576,000 Newton meters. Put the equal sign there. Now, before I get the right side, let's just add those two numbers up. So I'll take that number and add that number. And that's the total torque caused by the bridge and the truck around that pivot point. So that's going to be 8,736,000 Newton meters. And because it is in static equilibrium, that has to be what the torque that FQ causes in the opposite direction. So that's going to be FQ times 17. So I divide this by 17, and I'll just have FQ in a second, just like that. Boom. I'm not worried about sig figs right now. Let's not make it any difficult right now. Let's just, whoa. Let's drag my box. And box off the answer.